Tonight on Nova, it is the world's most active volcano. Its lava destroys everything in its path. But the ferocious beauty of Mauna Loa plays a dramatic role in the evolution of the isolated islands of Hawaii. Against the lush backdrop of land and sea, witness the creation of new islands and the joy of scientific discovery.
I think we got it this time.
Oh, wow! Yeah!
Hawaii, born of fire.
Funding for NOVA is provided by Merck. Pharmaceutical research, improving health, extending life. Merck, committed to bringing out the best in medicine. And by Raytheon. Through a commitment to technology, Raytheon offers a broad line of general aviation aircraft. Raytheon, expect great things. Major funding for NOVA is provided by the Corporation for Public Broadcasting and by annual financial support from viewers like you.
The ancient Hawaiians believed that the goddess of volcanoes, Pele, was born of the marriage of earth and sky. She was a destroyer. Unforgiving in her wrath, she incinerated everything that stood in her way. Even scientists who come to Hawaii to study volcanoes invoke her name with respect. To look at the lava that Pele still sends us is to catch a glimpse of the deep interior of the Earth, a seething inferno hardly changed since the formation of the planet more than 4 billion years ago.
You get this enormous sense of power, this enormous vibration and deafening noise. And really, they take over your body. There's a certain romance working with volcanoes, and it's this opportunity, I think, to combine this level of excitement with trying to solve a geological problem. In other words, try to figure out how does a volcano work? What's the nature of the magma that's supplying the volcano?
Mike Rhodes and other scientists come to the world's most active volcano in search of answers to some of the deepest mysteries about the planet's interior and the formation of its surface from molten rock. But they also come because of a story as old as the Earth itself, the creation of new land and the arrival of life. Here it happens almost overnight, drawing scientists to this natural laboratory to learn about the twin forces of destruction and creation. Though this is some of the youngest and harshest land on Earth, life can be found in every corner, spreading explosively. Old land is covered, and new land is created, and faster than almost anywhere else on Earth. Lush new forests arise from the ashes of destruction. This drama of decimation and rebirth began over 70 million years ago, when the first Hawaiian islands broke the surface of the mid-Pacific, eventually becoming islands of life like the Earth itself. They're more than 2,000 miles from the nearest continent, the world's most isolated archipelago. Although there are hundreds of active volcanoes in a narrow belt around the Pacific, the Hawaiian volcanoes are different. What drives them is still not known for sure, but there is a compelling theory. It holds that there are fixed plumes of superheated rock rising slowly through the Earth's mantle. Perhaps starting at a depth of more than 1,000 miles, one of them reaches the surface beneath the big island of Hawaii and creates what's called a hotspot. But the immense engine that drives it is not well understood. Its heat may come from the Earth's very core, or the plume may rise from a deep region of radioactivity, an immense perpetual meltdown. Made buoyant by intense heat, this huge upwelling of rock, or magma as it's called, rises a few centimeters a year. Nearing the crust, the rock melts and forces its way to the surface, where it erupts as lava and creates new land.
On the island of Hawaii itself, we've got four very large volcanoes that have grown within the last 1 million years from the ocean floor up to heights of about 30,000 feet.
Hawaii's Mauna Loa is the world's largest volcano. Its huge dome dwarfs its younger but extremely active neighbor, Kilauea, to the right. Since 1983, Kilauea has been erupting almost continuously through a series of cracks or rift zones.
Well, we think we know quite a good deal about what's happening inside Kilauea volcano. Although Kilauea volcano has a single crater at its summit, magma often manages to push its way through the flanks of the volcano along one of these two rift zones and actually break the surface and lead to an eruption.
Lava erupts explosively in spectacular 1,000-foot fountains when the system is under great pressure from below. The falling red-hot cinders build up steep cones. But when the fountains die down, the eruption is by no means over. Inside this smoking cone is a seething cauldron. A crust of hardened rock floats on a lava lake. The lake is fed from below, and it overflows through a tunnel at the base of the cone. As the streams spill down the slopes, the lava melts and erodes the underlying rock, carving out channels. The lava splatters up the sides of these channels, and a roof begins to form. Eventually, the channels will be entirely covered over, forming underground tubes that sometimes stretch for miles, only occasionally coming to the surface. Where the roof of an underground tube has collapsed, a skylight exposes the river of lava. Kilauea's activity is under constant scientific observation. As part of the effort to understand it, Mike Garcia of the University of Hawaii collects samples of lava for chemical analysis.
We're out on Kilauea volcano, looking at some of the youngest real estate on Earth. The purpose of our sampling program, which has gone on now for over 8 years, is to try and understand how magma moves within the volcano.
To collect the lava, the lifeblood of the volcano, it takes a close encounter with Pele herself.
As you get close, you can really feel the heat from the rising gases from this skylight. What I want to do is see where I can approach the skylight, where it's not overhung, and be able to throw a cable in and try to sample a bit of the lava. This is probably the first place most of this lava is seeing the surface, so it's really quite hot.
The lava is over 2,000 degrees Fahrenheit. Standing here is like standing in front of a blast furnace. Garcia will essentially be fishing for lava. To collect a sample, he uses a long chain with a square steel pipe on the end. This pipe will dip briefly into the flow and scoop up some lava. Without protective clothing, Garcia has to move in quickly. The flowing lava pulls on the chain like a living thing. Sampling devices are often lost. The cable can easily get caught.
Okay, I think we got it this time. It was hung up on the edge. And there it is. This chain is really hot. This lava here that we just sampled is very hot, and it has cooled very little since it passed from the deep interior of the Earth.
Even so, the sample is quickly cooled with water, and Garcia can handle it in only a few minutes.
On Kilauea volcano, there are a variety of different kinds of analyses going on. There's geophysics, there's ground deformation, there's gas chemistry. And looking at the lava is just another tool to try and understand what's going on inside the volcano.
From here, the lava continues to flow toward the coast. But about a mile downhill, it becomes blocked and is forced to the surface.
The lava we saw in the skylight was extremely fluid. As it passes down through the tube system and comes out in surface flows lower down the hill, the lava has lost more of its heat and temperature, so it's much more viscous. We're going to try and sample the edge of a Pohohoi flow here. You can see from all the orange in the cracks that it is molten just below the surface.
This is molten rock that only a few days earlier may have been a mile underground. It's like a thick paste and stretches into thin, glassy filaments.
By quenching the lava, we're freezing in what was there before we took the sample. Otherwise, it changes as it slowly cools. We want to see what was originally present in lava when in molten state.
After Mike Garcia has collected his samples on Kilauea volcano, he sends the samples to me, and I determine their chemical composition. And we're using this, the chemistry of these lavas to try and find out what's happening inside the volcano. In other words, what's going on in the volcano's plumbing system.
Although it's 15 miles from the summit, this is like all Kilauea lavas, with characteristic proportions of aluminum, titanium, silica, and other elements. This chemical fingerprint tells just how complex and extensive the Kilauea system is, but it tells another story as well.
The earliest workers on the island of Hawaii thought that the two volcanoes of Mauna Loa and Kilauea were interrelated. In other words, that Kilauea was the sort of a smaller satellite sitting on the flanks of the much larger Mauna Loa volcano. When we look carefully at the composition of the lavas from the two volcanoes, we see that they are quite distinct. In other words, each volcano has its own sort of chemical pattern which we can recognize. It also appears that they've been distinct for quite a long period of time. And so, in other words, the magma supplying these two volcanoes has to have had separate pathways.
Mauna Loa was born 500,000 years ago, when lava surged upward. Then, perhaps only 200,000 years ago, Kilauea appeared. All Hawaiian volcanoes were built this way, but except for those on the Big Island, all are now extinct or dormant. For a long time, no one knew why. But then it became clear that the story of the birth and death of these volcanoes was part of a much larger picture. It was discovered that the floor of the Pacific Ocean on which the islands rest is moving. It is one of 20 or so slowly drifting pieces of the Earth's crust called tectonic plates.
There's a whole chain of volcanoes which get progressively older as one goes along that chain. And this is very difficult to understand, except in the terms of an interacting plate and a hotspot. In other words, you have a fixed hotspot, and that the Pacific plate is moving slowly over that hotspot at roughly about 9 centimeters or so a year. And so that as this plate moves along, then you're gradually producing volcanoes along the plate as it moves.
For 70 million years, the plate has been moving across the hotspot, carrying old islands away while new ones are created. The old volcanoes die, erode, and eventually submerge, and they now form an unbroken submarine mountain range 4,000 miles long, anchored at its southern end by the Big Island and its active volcanoes. This process is far from over. To the east of the Big Island, a new volcano is rising. Still 3,000 feet down, Pele's newest creation is called Loihi. Under the shadow of Mauna Loa and 13 miles off the coast, Loihi is so deep there is no sign of it on the surface, and the only way to find out what it's doing is to dive to it. The research vessel Kila from Honolulu is approaching a position over Loihi. In tow, she has the submersible Pisces 5. Alexander Malahoff of the University of Hawaii is directing a study of Loihi. He and his crew approach the platform on which the submersible is mounted. The pilot, Terry Kirby, followed by Malahoff, climbs aboard Pisces. They have devised a way of safely launching the sub in the often rough seas. They enter and check the systems and watertight seals. When all is ready, air is released from the platform's flotation tanks, and it begins to sink. When they have descended well below the rough water of the surface, the sub will be released.
Kila, this is Pisces 5. We're ready to dive, over.
Roger, Pisces 5. This is Kila, standing by for dive, over.
60 feet down, the water is stable, and the launch of the submersible will be safe.
We're on our way.
Malahoff and Kirby move off under power, leaving the platform behind. Steep and jagged, the young island to be rises almost 3 miles from the ocean floor. This is Malahoff's 35th dive.
Loihi volcano has been probably building for 100,000 years or more. So Loihi is our clue to the infancy of the Hawaiian Islands.
That's the beauty of it, because we're able to observe the processes by which these Hawaiian Islands were formed.
In Loihi, we see essentially a volcano in its womb, the womb, of course, being the ocean.
At a depth of 3,500 feet, they make visual contact with the mountain. They are midway up the face of a wall of dark volcanic rock, exposed when a section of the mountain sheared off in a giant landslide. Their lights have a range of 30 feet, so they have to stay close to the cliff. So close, there's a chance of hitting it, maybe starting a dangerous landslide. Their ascent is slow and careful. Even so, the sub collides with an unseen overhang.
We have an overhang at 1,010 meters.
The vertical wall, still standing with slope, is stirred up with these translucent bacterial mats. So to back off, time is now 9:19.
They check for damage to the sub. Then they resume their ascent until radar shows they've reached the top.
Okay, Dave, we're on the bottom. We're at Pele's vent.
First discovered in 1951, Loihi was thought to be ancient and inactive. But in the 1970s, earthquakes were detected here, a sure sign of volcanism. And there were other clues as well.
It wasn't until 1980 when we first took bottom cameras down on the summit and we found the presence of hydrothermal vents that we realized, in fact, that this was an active volcano.
There is a lava chamber inside Loihi that heats the summit rocks. They warm the near-freezing ambient water to 90 degrees, causing a shimmering effect. The warm water picks up minerals from the volcanic rock, and deposits form as chimneys around the exit vents. The surface of the summit is a virtual desert, except for a yellow-brown bacterial growth that thrives on the chemical nutrients in the warm water. Only a few solitary bottom feeders and hunters are ever found here.
You really are researching the frontiers of Mother Earth. And you are, in many cases, the first human being who's seen that particular rock or that particular landscape or that particular animal.
Samples of Loihi's rock reveal that this volcano has its own chemical signature.
So the hot spot, in fact, is giving rise to several separate plumbing systems, one for Mauna Loa, one for Kilauea, and one for Loihi.
Although completely separate from those volcanoes, Loihi's interior follows the same basic plan. Only 150 feet below the summit is a reservoir of red-hot lava. When magma is pumped into this chamber, Loihi inflates as much as 12 inches in 3 days. When the pressure is great enough, the volcano can erupt either at its summit or through a rift zone on its flanks, much like Kilauea's. No one has ever seen Loihi erupt, but Malahoff believes it's only a matter of time.
We've never witnessed active volcanism taking place there. However, we know it's taking place because we've come back and we've seen piles of fresh lava in the same place.
As active as it is, Loihi won't reach the surface for several thousand years, but when it does, it will be a violent birth. A glimpse of the genesis of Loihi and all the Hawaiian Islands can be seen even today when lava flows from Kilauea hit the ocean. But there was more to the creation of Hawaii than volcanic eruption. When the lava created a platform where there was only water before, it became a magnet for living things. Marine life was the first to arrive. It flourished, even though it had to put up with periodic eruption. The eggs and larvae of fish, coral, and crustaceans drifted in on currents from many corners of the vast ocean. First one species took up residence, then another, then another. In a primeval act of creation, lava finally broke the surface of the water, and new land formed. In the beginning, the land was barren and lifeless, in every sense a desert island. But as the islands grew, almost every climate type on Earth developed here. On nearly 14,000-foot peaks, there were frigid alpine conditions. Lower down, enveloped in clouds, there were rain-soaked highlands. Each zone was a clean slate, where some form of life had a chance to make a start, even where fresh lava baked in the sun, and the Pacific pounded the rock into black sand. Birds arrived, some migrating, some blown off course. Many came from Southeast Asia and the South Pacific, where most Hawaiian plants and animals have their closest relatives. Just one bird could carry dozens of seeds and other hitchhikers. 3/4 of all Hawaiian plant species probably came from seeds brought by birds. The rest drifted in on the water or the wind. Getting here was hard enough. Survival was even more so. Seeds might arrive, but without soil, how could they take root? Without plants at the base of the food chain, what animals could survive? Even if they did, without mating, they would vanish without a trace. On the average, only once every 50,000 years did a chance arrival establish a permanent population. Until 1,500 years ago, there were no people. Perhaps the first plant on some ancient island was lichen. Covering the rock like a gray carpet, it needs little more than sunlight, moisture, and air. Even today, after an eruption, conditions on lava flows are brutal. But in only a few years, ferns appear. As ferns and lichens decay, organic material accumulates, mixes with lava particles, and one of the Earth's most fertile kinds of soil begins to form. Then a forest claims the land. It not only has rich soil, but also a reliable source of water. On the windward side of the Big Island, trade winds bring water-laden clouds. When they meet the great bulk of the mountain, the clouds are cooled and a gentle rain falls. This is one of the wettest places on Earth. 300 inches may fall every year, high on the sides of the volcano, nourishing the growth of a rainforest. What was once windswept rock is now moist and sheltered. As the forest grows, there are places to hide and things to eat. New life moves in. It has taken untold generations for this cast of characters to descend from the few that made it. In that time, they have changed so much that over 90% are now endemic to Hawaii. They occur nowhere else in the world.
Well, I think this looks like pretty good habitat, Steve.
For biologists like Rosie Gillespie and Steve Montgomery, this is a living laboratory.
You see the little silk threads all over the place. Which is a good sign for the tetragnatha.
Those are the traveling threads.
Here it's possible to see again and again how living things colonize brand new habitat.
These are wonderful areas. You can see that there's a thread that runs through in there.
These spiders, like everything else native to Hawaii, are descended from a long line of great travelers.
Spiders originally probably got here through ballooning, which is a funny way that's unique really to spiders of dispersing. They do this just as spiderlings. They get out of the egg sac and then they will go up something like up to the top of a branch or something. And then they'll put their little abdomens up in the air and let silk out, and the wind will pull on the silk, and it'll pull more and more as they let more and more silk out, and then they'll finally take off, kind of like Mary Poppins takes off with her umbrella, and they'll just sail up into the air. Imagine a little spider just ballooning its way over thousands of miles of ocean. But just occasionally one of them has made it, or perhaps two of them made it.
But then they had to find suitable habitat and a mate. The odds are staggering. Only 4 out of the 100 major groups of spiders are well represented in Hawaii. And scientists conclude that all these must have descended from only 4 successful arrivals over 70 million years. The isolation was so great a barrier to most animals that among the creatures native to Hawaii, there are no snakes, no frogs, no ants, and except for bats, no land mammals. Things common throughout the world never made it here on their own.
Because Hawaii is so far from the continent, so very, very few plants and insects and other spiders and whatnot were able to arrive. So those few successful colonists essentially won the sweepstakes. They had all these resources of food plants and all these mountain peaks and valleys to populate And as they did, they evolved and changed and adapted in all these ways to make use of all these resources.
We're heading right away, and
With all the collecting Montgomery does, he never ceases to be amazed by his discoveries.
Well, these tree ferns are a good spot to find that carnivorous caterpillar that likes to hide on ferns. This is a little tree fern. Wow, look, right there. See that notch?
Amazing.
You'll find them hiding in between the leaflets. So they're quite a dominant predator on the foliage in Hawaii, and that one's only about
How in the world did you see that?
Well, turning over the fern helps because they bend down a little bit, but it took me about 3 years to figure out where that species was hiding.
Montgomery was the first to describe these caterpillars and to make the discovery that they were carnivorous. Found only in the Hawaiian chain, this is an ambush hunter that waits for unsuspecting prey. It evolved from a plant eater into a predator. This was such a successful adaptation that there are now at least 18 species throughout the islands. Being able to catch prey instead of eating plants gave these caterpillars an edge. What began as a shift in behavior led to a whole new way of life. But there is more to survival than finding food. As if the challenge of gaining a foothold here was not enough for plants or animals, they faced repeated volcanic eruption. To assess how life coexists with a volcano, scientists needed some notion of how often it has erupted over time. Until recently, they had no idea. Historical records of Mauna Loa's activity extend back only to the early 1800s, not far enough to understand long-term patterns. Even the Hawaiian people have not been here long enough to record much of Pele's history. Dating these eruptions had always been nothing more than guesswork. Jack Lockwood, a geologist with the Hawaii Volcanoes Observatory, has discovered how to tell the frequency of Mauna Loa's eruptions in the distant past. It grew out of his work, mapping the lava flows on the surface of the mountain. At the summit of the volcano is a caldera from which thousands of flows have erupted to build the mountain, but only the newest are visible.
We may see perhaps 500 to 600 flows presently at the surface. Those flows have a spectrum of ages from more than 10,000 years to the youngest flow, 1984 age.
Today, Lockwood has picked out a flow for dating. He's looking for a place where the contact between that flow and the older one underneath it is very well defined. There is no way to test the lava itself for age, but sometimes remains of the plants in its path were preserved as charcoal under the cooled flow.
If we can find bits of charcoal, it'll be dated by the radiocarbon method. Then we'll know when the plant died, and it was, of course, killed by the lava flow, so that will tell us the age of the lava flow.
He is joined on the expedition by his wife and collaborator, Marty Lockwood.
You ready to go? You got the pick.
They search along the contact line between two flows, the most likely place to find the occasional plant remains that escape total incineration.
Hey, look! Far off, look at that. Okay, hey, that's really neat. You can look at the way the Pahoehoe came down through here on top of there. Look at this. Hey, this is a good place. We're giving it a shot. Okay, this one comes out. Okay, this one's coming off.
I'm having trouble pulling with it.
Okay. Oh, it's dark. Oh, wow. Okay.
There's the charcoal.
Let's see.
Listening?
I don't know.
Or is it just an old root? I can't tell. Part of it's roots.
No, it's modern.
That's modern.
It's modern root.
It's a modern root.
The problem is that you've got to find actual carbonaceous charcoal that was cooked by the lava flow. there's lots of organic material. There's lots of plants that send their roots into the same zone, and those roots die, and they look like charcoal, but they're not the real thing.
Even though Lockwood has found over 300 samples in 12 years, this is like looking for a needle in a haystack, and the trip could easily end in failure.
Oh, it's loose. Great. Okay. Wow, look at the glass. Look at the glass in this one. It's really black. That's a good sign. Oh boy. Oh, look. See the black? Oh, there's plant impressions. Hey, okay, guys. Far out. Okay. Oh, beautiful. You can see where the root went down through here. Okay, we've now, we found the essential thing. This is a place where a plant was growing 2,000 or 3,000 years ago. So now we're getting excited. Now we can see if it was carbonized. Oh boy. Oh wow. Yeah. Okay, far out. Here's a root. See the impression? You can see the impression of the plant. That was a plant that was actually crushed. And right in the interstices of where that plant mold is, you can see the carbonation material. Anyway, more of Paley's history is being revealed. At times like this, you feel kind of funny. Or funny, and that's not the word, but I feel like I've been given a gift. Like Paley is sharing a secret. She's saying, okay, I'm going to help you find out what I was doing. I'm going to help you tell my story.
Oh, hey, look at this one.
Oh, far. Oh, wow. Good. Let me have those others, too. Oh, hey, neat. These are great. These are beautiful rootlets. Look at that. This thing probably weighs 1 gram. This is going to get submitted to a lab in Washington, D.C. at the USGS, and we're going to find out how old this flow is. I thought I was going to get skunked out there. It was just a really...
At Lockwood's lab, the charcoal samples are cleaned and weighed for analysis at the U.S. Geological Survey.
Now, this is what we call bomb-proof. This is a really good one.
In 2 months, the completed tests will show that these samples and the flow that buried them are 2,050 years old. Lockwood is adding the new flow to his map of Mauna Loa by using aerial photographs.
Out in the field, you're trying to determine where the different contacts are between lava flows. Each one of those lava flows is like a clock that's been frozen in time. On one side of the contact, you'll have a flow which may be perhaps 1,000 years old. On the other side, a flow which perhaps is 2,000 years old.
Lockwood's dates for hundreds of flows show that in the last 10,000 years, the slopes of Mauna Loa have been almost completely resurfaced by its eruptions. But the forest always comes back. Where the activity is greatest, vast areas have been buried many times.
The primary impact of our dating efforts out here has been to shorten dramatically the amount of time available for all sorts of processes, whether it's soil alteration or forest growth or insect evolution or whatever. It has to happen much faster than people had ever realized before.
It was a revelation for biologists. On the Big Island, some mature rainforests, once thought to be thousands of years old, were now known to be only a couple of 100 years old. Volcanic eruptions were forcing rapid cycles of death and rebirth. It's only now becoming clear how this volcanic activity creates new opportunities for life. When lava slashes through the forest, it kills nearly everything in its path. What isn't incinerated is buried in ash. These were once trees, but were encased in flying lava. Everything in the path of an eruption would seem doomed. But somewhere, something always lives. This Kapuka, as the Hawaiians call it, is an island of survival where life not only endures, but evolves with extraordinary speed. Biologist Ken Kaneshiro of the University of Hawaii has been trying to understand this process. He and his assistant Bill Pereira are crossing an old lava flow on the way to a large kapuka that was created after an eruption of Mauna Loa in 1855. This kapuka is a remnant of an ancient rainforest. Though birds migrate in and out, small creatures like insects rarely leave its safety. For the past 3 decades, Kaneshiro and a team of researchers have been investigating the way isolation affects the evolution of one family of insects. This ordinary-looking Drosophila fly is part of a remarkable story. Hawaii has 1/4 of the world's Drosophila species, in fact, more than 800. And yet, all 800 species may have descended from a single ancestral pair that arrived 20 million years ago.
It looks pretty good in here, Bill, but let's get further up.
Kaneshiro's group has been tracing the family tree of the flies in this kapuka over many generations.
That looks pretty good around here. Let's do it.
Using bait to attract flies, they compare those caught here with flies of the same species in another kapuka, only 1/4 mile away.
Smelling pretty good. Go ahead.
It's almost nauseating. We'll get a lot of flies.
They color the baits with red dye to make them easy to find again.
Now this looks like a good spot, Bill. Let me have one of those tacks.
The 2 kapukas Kaneshiro studies here were created 140 years ago. Since then, the 2 fly populations have been breeding in isolation from each other. Kaneshiro and others have begun to detect subtle differences between the flies in this kapuka and those in the adjacent one.
We've been doing some studies comparing the genetics of the population in this kapuka compared to the population in adjacent kapuka. And within the very short period of 140 years or so, there's been very significant gene frequency differences occurred between these 2 populations.
These differences suggest that the flies have taken the first step in the evolution of a new species. Kaneshiro is certain he has found out how this process occurs so rapidly.
These kapukas create situations where Drosophila, for example, are subjected to small population sizes. And it's this small population that is most important for understanding speciation process.
It was known that a sudden reduction in numbers for any animal could lead to inbreeding or even extinction. But what Kaneshiro's group found came as a surprise to many and remains controversial.
Our idea is that changes within the sexual environment, within the mating behavior of these flies, have been more important in the speciation process than most of us ever believed before.
Here's how it works. Most Hawaiian Drosophila flies have elaborate mating rituals. These rituals often begin when rival males, like these 2, fight to establish dominance. The victors of contests like this will form a small class of super males, which dominate the courtship arena. The other male will join a large group of losers that don't stand a chance with the female flies. During courtship, this male raises his abdomen over his head and tempts the female with scent secreted from its tip. Like many female flies, she's choosy and shows interest only in super males, the most accomplished suitors. But in a new, isolated kapuka, the population is so small that there may be hardly any super males. This means the choosy females may never mate. This male tries to mount a female, but he doesn't meet her high standards, and she shakes him off unceremoniously. However, some females relax their standards and will now mate with virtually any male that comes along, including the losers that normally never mate. These males introduce new traits into the gene pool by mating often with indiscriminate females. These actively breeding flies are nature's hedge against extinction when the population is severely reduced. This female's offspring will be better adapted and increasingly numerous. A kind of genetic revolution is underway, and it may be the first step in forming a new species.
What we have here is a situation where you have volcanic activity creating kipukas, which results in small population sizes in these flies, which then causes a shift in the mating system, which then results in a shift in the genetic system, the genetic background of the population, which then leads the population in a different evolutionary pathway.
Every time lava plows through forest, dividing it up, separating once continuous populations of plants and animals, there is a potential for change. But while the volcano is rearranging the existing landscape, it's also creating an entirely new and hidden world. When this lava drains away after the eruption stops, what's left is a network of caves. After the rock cools, the forest returns to the surface and around the mouth of the cave. Frank Howarth of the Bishop Museum and Fred Stone, a colleague from the Hawaii Community College, have been exploring these caves for 20 years. The rock of Mauna Loa is honeycombed with caverns like this one.
This cave is only 110 years old, being in the 1881 lava flow. As soon as the lava cooled and vegetation started to grow, they send these roots deep into the lava, getting moisture and nutrients from the rock.
The ceilings are festooned with these roots, making a curtain of living stalactites. The tunnel snakes for miles up the mountain. As they go deeper in the cave, the air becomes stagnant, humidity is 100%, and the temperature is a constant 70 degrees. The darkness is total. The only sound is the steady drip of water.
This low passage going down and then back up. It opens up ahead.
The caves are lightless, isolated, and doomed to certain burial by newer lava. Most biologists assume that except for the entrances, they would be hostile to life forever.
It's so important in biology if you assume there's nothing there, and then it's a self-fulfilling prophecy that nobody finds it.
But in 1980, Frank Howarth discovered a system of totally cave-adapted life here that defied conventional scientific wisdom.
Oh, there's a caterpillar on the root there. Oh, yeah. I wasn't really looking for cave life, so that when I saw an animal in the cave, I knew that it was of some biological interest. I had assumed these were accidental animals or visitors to the cave like myself. For a while, every trip was yielding new species. That was when I realized that there was nothing anywhere else in the world that even came close to this, that we must be onto something. It wasn't long before the pieces started coming together of this being a complete ecosystem, fed by tree roots and organic material that percolates in from the outside through rainwater.
Oh, look, I think there's a cricket over here.
Yeah.
As soon as roots appear, creatures like crickets are soon to follow. Opportunists and scavengers, they can eat almost anything, from vegetation to other insects. Although descended from crickets of the forest, these have been transformed as they evolved in the caves. Headlong leaps in the dark are dangerous, so once powerful jumping legs have become long and spindly.
This species only jumps when you threaten it with imminent squashing. Otherwise, it'll just run away, and most uncricket-like.
For most cave creatures, without daily or seasonal cycles, time loses its meaning. Without light, eyes often become useless and blind. There is a sensory shift. Many have acute senses of smell and hearing. Others feel their way around with elongated antennae. Completely cave-adapted, these crickets could never survive a trip above ground. They had to come in from another cave. When the lava cooled, it shrank, forming a network of cracks. In their never-ending search for new places to live, crickets and other creatures use these cracks to migrate from old caves. Like a new volcanic island, the cave was a harsh frontier. But there was little competition, plenty to eat, and safety from predators. Like a Kapuka, this was another island of opportunity for colonists.
The new species aspect was exciting, but to put it together and to figure out how the ecosystem worked was tremendous.
There were creatures here that had all survived the same harsh test, adapt or perish. And when Howarth found them, he found a whole system of life thriving in an island of permanent night. One of the most profound lessons of the Hawaiian Islands is that few places on Earth are too bleak for plants or animals to gain a foothold. Life here has turned barriers into stepping stones. For new arrivals, profound isolation meant freedom from competition and safety from most predators. What once was naked rock has in only a tick of the clock of geological time become lush with living things, all descended from a handful of hardy pioneers. What began as a desert island became a giant mountain. Lava will one day cover everything on the slopes of Mauna Loa and Kilauea. But for every act of destruction, there will be an act of creation and a new stage for Hawaii's evolutionary drama. And presiding over it all will be Pele, the goddess of fire. Pele came from the west, visited all the islands in turn, and when she saw the Big Island and its vibrant life, she made it her home. But Pele is a restless goddess, and one day she will move on and raise up other great mountains, for she is the maker of the land.
Educators, educational institutions, and organizations can purchase this and many other NOVA programs for $19.95 plus shipping and handling. To order, call 1-800-255-9424. Nova is a production of WGBH Boston. Funding for Nova is provided by Merck. Pharmaceutical research, improving health, extending life. Merck, committed to bringing out the best in medicine. And by Raytheon. Through a commitment to technology, Raytheon offers a broad line of general aviation aircraft. Raytheon. Expect great things. Major funding for Nova is provided by the Corporation for Public Broadcasting and by annual financial support from viewers like you.
This is PBS.
Next time on Nova, is the sky falling?
We heard this tremendous crash and saw this huge hole.
Comets really do impact planets. A big one could come in at any time.
The Doomsday Asteroid. Next time on Nova.
For more information about Nova, visit the PBS homepage on the World Wide Web at www.pbs.org.